Here's another example problem we're going to do. Slightly depressing, but all of the same. We need to know how to calculate this kind of stuff. Okay, so here goes. The first atomic explosion was detonated in the desert north of Alamogordo, New Mexico on July 16th, 1945. What percentage of the strontium-90 originally produced by that explosion still remains as of today? The half-life for strontium-90 is 28.9 years. So to make this calculation easy, for today, we'll just say July 16, 2022, so we get just an even number of years. Okay. So we're going to use the integrated half-life equation for this. And so recall that one goes as the natural log of A time t equals negative kt plus the natural log of A initial. And we are going to solve for this ratio right here, as I'll show you in a moment. Okay. So I can rearrange this equation in the following way. So I'm going to combine the logs over here. I'm going to say natural log of A at time t minus natural log of A0 equals negative kt. And I recognize when I have two logs being subtracted, I can combine those as a ratio. So that becomes the natural log of the ratio at A at time t to the natural log of the ratio of A0, and that equals negative kt. And now I'm going to take e of both sides of this thing, and that now gives me the ratio of A at time t relative to A initial, which just equals e to the negative kt. And because the problem asks me what percentage of this remains, I'm already set up to calculate that, right? This ratio here will give me my percentage that remains. Okay, so now I've got to get a half-life, or excuse me, a rate constant from the half-life. So I know that T1/2 for first order is 0.693 divided by K. I'm going to rearrange that to say K equals 0.693 divided by T1/2. So we can keep all of that in years for this calculation. So that's 0.693 divided by 28.9 years. And so we'll get a half-life out of that. Or excuse me, a rate constant rather, 0.693 divided by 28.9 equals. So that's going to be 0.02, let's say 401 over years. Okay. And now we've got to get a time out of that. So we'll just say from 2022 minus 1945, that's going to be, I was going to do it in my head, but I got a calculator right here. 2022 minus 1945, something like 77 years. Okay. And so now this calculation for just estimating like the percentage of something that remains is really straightforward. So we can now just say that's e to the negative k, which is 0.0240 over years times 77 years. And that will give me a decimal that I can then convert into a rate constant. So, or excuse me, a percentage. So times 0.024 equals, and I'll say times 1 negative, and then now I'm going to push that E button. And so I get, that becomes 0.158. And now to turn that into a percentage, I just multiply it by 100. So that's 15.8% still remains 77 years later. So that's why I kind of said this is a depressing calculation. If you think about this, right, this was this particular detonation was a test on American soil. And 77 years later, there's something like 16% of that material is still around. And many of you are probably aware that's not the only atomic explosion that we've detonated. So just 2 weeks later, August 6th, 1945, that's when the bombs in Hiroshima and Nagasaki were detonated. Okay, and since then, there's been dozens of tests. So Japan has been a worldwide leader in the proliferation of nuclear testing, and rightfully so, because you can see every time we set one of these things off, we eject all of that material all over the world. It becomes well mixed all over and will take decades to disappear. Okay? So like I said, depressing calculation, but it's important we know how to do this so we can make informed decisions for the future. Okay? So I'll see you in the next video, folks.